read question number 3 before you proceed to the rest of the video. So in this question and the experiment, they're using milk agar. That means they used powder, and of course they added water, and they also added milk. So milk is white, that's obvious. Okay, so that's one of the things that we need to take note of, although it is not shown in or very obvious in the experiment. Okay, so if I were to give you a side view of what 4 holes are cut in the milk agar looks like, then it would look something like this. They actually scoop up towards the same depth, okay, so that you can put the different solutions according to the picture. Okay, the other information that you need to know is that for now, protease works best in pH 2 or an acid medium. So how does this work? We can first, before we move on, can we just write down the word equation to show the effect of protease on milk proteins? So proteins will be broken down in polypeptides or peptones, okay, by a protease that is inside the milk. Sometimes students would like to continue this equation to break down polypeptides into amino acids, but the enzyme working on these is different from the protease that is working on these proteins in the first place. So this would be the desired answer. So after 1 day of incubation, means allowing the experiment to be so that it will the enzymes can work on the proteins, the agar plate is put under light to observe for clear zones around the holes. Now what does that mean? This is what it means. So milk is white. So if this was the well where you put protease, then a protease that is in contact with the proteins in the wall will digest it. So the white protein will become soluble polypeptides, which will give you a clear zone. So over a period of a day, the protease will be able to move into the agar and digest the areas around it, giving a clear zone. You may want to pause the video to write the answer for B part 1 and 2. To explain B part 2, let's see in which wells will protease be working. So protease in well A will definitely be able to digest the proteins around it. So this will give you a clear zone. Okay. B, protease in concentrated hydroxide solution. This one will cause it to denature, and therefore there will be no digestion. So this will be the white zone. For C, boiled protease will also denature the protease and will therefore lead to a white zone. And distilled water is not an enzyme. There is no protease. So with the absence of protease, protein cannot be digested. It will also be the white zone. Okay, so why we look for clear zones around the holes? Because protease will break down white milk, okay, milk proteins into soluble polypeptides. Okay, let's move on to question C. Explain the purpose of the distilled water in hole D. So once again, explaining the purpose, you would need to write down what the purpose is. If they were to say state the purpose of whole D or well D, then it will be sufficient to say it is a control. However, they use the word explain, so the purpose is always linked to the purpose or the investigation of the experiment, and therefore it needs to be written specifically. So it is a control to show or to compare the action of protease on proteins in different conditions, which is what the experiment is. Okay, it could be amylase on starch, it could be lipase on fats. So what is in the parenthesis will change for different questions. Okay, so control will not be sufficient if they ask you to explain. You must link it back to the purpose of the experiment.